No, you cannot.
So trigonometry. Just hold on. Let me. Okay. So take a note of the topic first, and then let's start the trigonometric in this discussion.
I read
Okay. So first of all, see, we will learn to use the trigonometry. So see, for that we have to take the right angle triangle first, right? So let's start from the right angle triangle. Hmm? We can use for the other triangle also, but most probably, in the general cases, we take the right angle triangle and then use the trigonometry, right? And what's the trigonometry is actually, see, in trigonometry, you will learn the relation between the sides and the angles, the ratio of the sides and the actually angles. So if I'll take a triangle, that's my right angle triangle, A, B, and C. So triangle A, B, and C is a right angle triangle. Right angled triangle. And right angled at right angled at B here. Correct? So now
it.
have a look. The side opposite to this right angle is known as the hypotenuse that we know. This is known as the hypotenuse.
Mm.
So here AC is my hypotenuse. AC is the hypotenuse. Clear? Now, what about the AB and
A,
BC?
those are just the sides, right?
That would be,
I do just like the sides. What do they call them?
yes, just let me use the headphone. Just give me a minute. I'm audible to you, Midni.
A, B, B, C is the adjacent, right?
Sorry.
B, C is the adjacent, is it not? B, C is the adjacent, right? I think. Am I wrong?
Your voice is very low for me. Just hold on. Nothing. Okay, please try to speak up something.
BC is the adjacent, right?
Okay, so I'm clearly audible and visible to you, right?
What?
I'm clearly visible and audible to you. Okay, okay, okay. Okay, so what did you say? Please repeat. I think there's a very low voice. Okay. Okay, so shall we start, Ridni? Okay, see. Now, in trigonometry, see, you will learn about some ratios of sides. If I ask you how many possible ratios are there, so let's try this, right? So, sir, we can take, we will start from, so we can take, let's suppose, BC over AC. If I ask you how many possible ratios are there, so the very first ratio that I can take is BC over AC, right? So I have these sides AB, BC, and AC. And with these three sides, I need to take the ratios. Correct? So now BC over AC, first ratio I have taken. Second ratio, possible ratio that I can take is, let's take AB ratio AC. And third ratio that I am taking is BC over AB. Now, fourth ratio is just reverse of it. I'm taking AC with BC. Fifth ratio is, let's take AC over AB. And sixth ratio is, I'm taking AB over BC. So do we have any other option here?
Oh,
No, right? Yes. So we have these six options only. So if you will take the ratio of all these sides, the all possible ratios can be BC over AC, AB over AC, and BC over AB, and this one, and this one, and this one, right? So these ratios are, now have a look. A very important concept of theta. This symbol represents theta.
represents
This is
what?
known as the theta. 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 Theta is nothing but actually the angle. It's actually the angle. So let's suppose I'm taking the angle A, and that angle will be my acute angle for here, but let's not restrict. But let's take, if I have a right angle triangle, so then if I have a right angle triangle, then of course A and C is going to be my acute angle, right? A and C, angle B is my 90-degree. So angle A and angle C will be my acute angle. Correct? So let's take, I'm taking angle A and representing angle A. So let's take me the symbol theta here. So I'm taking angle A. It's a kind of, I am looking from, see, this is a tower. Let's suppose this is my tower, right? This is the height of the tower. BC is the height of the tower. And this is the, we can say the distance from the foot of the tower. And this is my eye. I'm looking from here at the top of this tower. Let's suppose this is my tower, right? So if I'm looking from A, this is going to be my theta. So if I'm taking A point, so the A point, the angle that the point A form with this point C. If I look at point C or at the tower, so the angle formed with the base will be my theta here, right? You can assume in this way. So what's the theta? The angle formed at point A, right? Now, this is my theta. So see, if I'll take these ratios, these are the only possible ratios. The each ratio have a specific name here. For example, BC over AC. If I'll take BC, so if this angle A is my theta, angle A is my theta, so the angle opposite to this angle, the side which is known as the opposite side. Opposite side. And the side that is in touch with it, that is known as the adjacent sides. Right? So this is my hypotenuse. Hypotenuse will be fixed, which is my fixed. Why I'm saying it is fixed? Because see, if I'm taking angle A, so its opposite side will be my BC, correct? And its adjacent side will be AB. And this will be going to be my hypotenuse. AC is going to be my hypotenuse. So hypotenuse will be fixed. But just think about it. If I'll take the angle, C, same situation is there, but are people that here at the top and is looking down, right?
Okay.
I'm taking, let's suppose, angle C now. Angle C is given. So in that case, see, the hypotenuse will be fixed. This hypotenuse is going to be fixed. Why? Because this is the opposite of this right angle, correct? Now, what about the opposite side? So angle is this one. So this is going to be my opposite side, if I'm not wrong. This is going to be my opposite side of this theta. And this is going to be my adjacent. Clear? So if I'll change the position of the angles, so hypotenuse will be fixed, but other two angle will decide which is going to be my opposite side and which is going to be my adjacent side. Okay. So hypotenuse is fixed, but your opposite and adjacent sides are not fixed. It depends on the theta or the angle I am taking. Okay, great. So now ratio of BC and AC. So we have a specific name. So BC and AC. So ratio of BC, that is my opposite over hypotenuse. Opposite over hypotenuse. So opposite over hypotenuse is known as the sine. So opposite over hypotenuse is known as the sine. Right? Now AB and AC. Look at this diagram. I'm taking the angle A. So come on. From angle A, this AB is my adjacent side. AB is my adjacent side. Adjacent. Adjacent over hypotenuse. Adjacent over hypotenuse is known as the cosine. If you will take the ratio of adjacent over hypotenuse, that will be my cosine. Now BC. So BC is opposite side over AB. AB is my adjacent side. So opposite over adjacent. And opposite, this is my triangle. So the opposite is, this is my opposite side, correct? And this is my adjacent side. So opposite over adjacent, that is known as the tangent. Tangent. Okay. Now, what is AB and AC with me? Please tell me. AC is my hypotenuse.
What is adjacent? Adjacent.
Yes. And BC is going to be my opposite, no?
Yeah.
I'm taking along the A only. So A is the theta, right? So angle A is equals to theta. Please keep in mind. I'm taking angle A only. So hypotenuse AC is my hypotenuse and over opposite. So it's just reverse of first one. Can you see? Opposite over hypotenuse and it's hypotenuse over opposite. So the reverse of sine is actually known as the cosine. Oh, sorry, cosecant. Next. Do you know the name of the next?
AC is hypotenuse over adjacent, which
Yes,
is
hypotenuse over adjacent.
which is
So that would be my hypo over adjacent.
that's cosine, right? Cosine.
That would be my opposite of cosine, that is secant.
Oh, okay.
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 Right. Last. AB and AC. So what is AB? So AB is going to be my adjacent.
That's cosine, right?
And opposite, correct?
That one's cosine, right?
Which one?
AB over BC, number 6 is cosine, right?
Yes. So that's my opposite side and which is not the cotangent.
Okay.
Okay. So tangent and cotangent, cosine, secant, sine and cosecant.
Hmm.
Right? Take a note, please.
Yeah.
And once it's done, please let me know.
I wrote them down.
That's done, right? Great. Now have a look. So we have some short forms, short names for these trigonometric ratios. These are known as the trigonometric ratios. Why the ratio word is there? Because we are taking the ratios of the sides. AB over AC, BC over AC. These are the ratios of the side, isn't it? That's why we call it as trigonometric ratios. Clear? Great. Now we have the short forms. Okay, second white screen is visible to you. Medni, white screen is visible to you.
It's visual.
Thanks. So now have a look. So the short forms are that I'll use during the discussion. Yes, come on. So sine that I'll use is sine theta. Sine theta. And for the cosine, we will use cos theta. And for the tangent, we will use tan theta. And cosecant that I'll use cosec theta. For secant, I'll use sec theta. And last, cotangent, I'll use cot theta. So this is the triangle. This is 90 degree. This is my theta I have taken. And these are the abbreviation that I'll use, right?
Why are we using these thetas at the end?
Theta, this one. Theta actually represents the angle, which angle I am taking. It can be,
Okay.
it's not necessary that you need to use the theta here. You can use directly, you can write down the name of the angle also. For example, sine of A. If I'm taking A angle, so we can write down sine A. Instead of theta, you can write down sine A also. Okay, this is a Greek word actually, the theta, so that usually we use for representing the angles. But we are not restrict with this one. So we can use the sine A, or here cosine of A, that is my cos of A. Or we can use tan of A. And then here it can be your cosec A. Similarly, we can use sec of A, and this is nothing but my cot of A. Cot of A. Clear? Right.